October 6, 2020, the Nobel Prize in Physics is announced. The award goes to a team of scientists for proving that a specific object exists right at the center of our galaxy, one that had been suspected for decades but never actually seen. This wasn't a sudden discovery. It was the culmination of a 30-year race between two rival teams, who spent 3 decades staring at the exact same patch of sky. They were hunting for an answer that would finally confirm a prediction many scientists thought was just a mathematical fluke. The mystery started in the 1970s, when radio telescopes picked up an intense pinpoint of energy coming from the direction of the constellation Sagittarius. It seemed to be coming from something incredibly compact and massive. Astronomers named it Sagittarius A star. You might wonder why it took so long to identify. The problem is, the center of our galaxy is hidden, behind 26,000 light-years of gas and dust. To an optical telescope, it's a complete blackout. It's like trying to see a single candle through 100 meters of thick fog. The dust scatters the light until there's nothing left to see, but infrared light can pierce through that fog. By the early 1990s, telescope technology had advanced enough for astronomers to finally see through the galactic dust. In Hawaii, Andrea Ghez at UCLA began using the Keck telescope, the largest on Earth at the time, to track the stars at the very center. On the other side of the world, she had a rival. Reinhard Genzel at the Max Planck Institute was using the European Southern Observatory's telescopes in Chile to go after the exact same target. 2 teams, 2 continents, same invisible goal. Their plan was to use a new technique called adaptive optics to remove the blur of our own atmosphere. By getting the sharpest possible images, they could track the movement of individual stars near the center. Because gravity reveals mass, the way those stars moved would reveal exactly what was hiding in the dark. The first images from the 90s were extraordinary, but messy. Hundreds of stars packed so tightly they looked like a blurry smear. But over years, the smear resolved into distinct moving points, visibly changing position, orbiting something with a massive gravitational pull. 30 years. Try to imagine that level of commitment. You're competing for telescope time, which is some of the most expensive resource in science, just to watch a single dot of light make one circle. You're betting your entire career on a project whose results won't arrive for generations. This wasn't a friendly collaboration. Ghez and Genzel pushed each other through 3 decades of competing publications and measurements. Each team was constantly checking the other's work by trying to beat it. That rivalry meant that by the time they reached a conclusion, the data was so overwhelming that physics had no choice but to accept it, and it was all thanks to one star that provided the precise evidence the world was waiting for. They called it S2. 15 times our sun's mass, it completes an orbit in 16 years. Reaching 7,650 kilometers per second, nearly 3% the speed of light, its path revealed the central mass, 4 million times the mass of our sun. For 30 years, 4 million times. Just 16 years. Same answer. Independent measurements from opposite sides of the world arrived at the exact same number. At that mass and size, the only object physics allows is a black hole. The data wasn't just suggesting it, it was insisting on it. In 2019, we got the visual proof. The Event Horizon Telescope collaboration used a global network of dishes to act as one Earth-sized instrument. They released the first direct image of a black hole in a galaxy 55 million light-years away. Then, in 2022, they turned those instruments on our own backyard, Sagittarius A star. It was exactly where Ghez and Genzel said it would be, exactly the size they calculated. Einstein's equations, written in a Berlin apartment a century earlier, were confirmed in the most extreme environment we've ever observed. The image was, to use a precise scientific term, insane. After 30 years of tracking invisible gravity, we finally had a mugshot of the giant at the center of our home. The Nobel Prize in 2020 cemented their victory, but the discovery proved something even more significant. We now know that every large galaxy has a supermassive black hole at its center. These objects aren't just sitting there, they shaped the structure of everything around them. You can see the evidence of this in the Fermi bubbles. These are two giant gamma-ray structures extending 25,000 light-years above and below the galactic disk. They are the remnants of a massive outburst from millions of years ago. Our galaxy still bears those scars. It proves that while Sagittarius A star is quiet today, it was once an actively feeding beast, consuming enough material to reshape the entire galaxy. What we still don't know is how it got so massive so quickly. Did these giant objects grow gradually, or did they form during the very first stages of cosmic history? That remains one of the great unsolved problems in physics. Look 4 billion years into the future, when the Milky Way will inevitably collide and merge with our neighbor, the Andromeda Galaxy. Over millions of years, their two supermassive black holes will spiral toward each other. When they finally merge, the gravitational waves will shake spacetime across the observable universe, in an event more powerful than anything we've ever detected. Nobody alive today will see it. The universe is patient. It operates on deep time, long after our own stories have ended. 2 scientists, 2 telescopes, 2 sides of the world, 30 years of watching the same patch of sky. And what they found was exactly what Einstein's equations predicted a century earlier: a black hole 4 million times the mass of our sun, sitting at the center of our galaxy, 26,000 light-years away, quietly holding everything together. The universe doesn't give up its secrets easily, but it does give them up.